Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about window scheduling. What are the priority classes and scheduling classes attached in the Windows API? How to implement them? And what are the advantages or disadvantages of the priority classes in Windows? In Windows operating system, we use a priority-based preemptive scheduling algorithm to schedule between different processes that are attached to any thread. Now, the processes that are running in the kernel, which are having lower priority, and suppose a high priority process enters the system, then the low priority process will be preempted by the high priority process. Now this guarantees that the high priority process will always run in the kernel. Now the code of the segment which is run by the Windows scheduler is known as a dispatcher. The dispatcher then dispatches and selects the processes among the windows and then allocates the CPU to them. The high priority thread will run in the kernel until it terminates, the time quantum expires, it calls a blocking call, or the termination is done by an interrupt, until and unless the CPU is allocated to the high priority thread only. Now when the low priority thread is running in the kernel and any high priority thread gives an interrupt to it, then it should be preempted for a preemptive kernel, and if it is a non-preemptive kernel, then the lower priority thread will continue its execution. The blocking call can be of anything that calls to an IO wait or a device wait. Now such preemption gives some real-time preferences for the processes to the process that are currently running over the process that are high prioritized. The window uses a 32-level priority-based scheme for the scheduling of classes, and generally there are two types of classes according to their priority. Number one is a variable class and number two is a real-time class. Now in variable class, the priority ranges from 1 to 15, whereas from real-time class, the priority ranges from 16 to 32. Now we should note that another process which is actually consuming the memory management has run on priority 0, and that is not changed by the kernel, which is considered also as a system thread. The dispatcher uses a queue for every scheduling classes, and it searches through the queue from high priority to low priority until and unless it finds an available thread to run. If it does not find any thread that is available to run, it then selects a special type of thread known as idle thread, which is then executed by the scheduler. Now the Windows API provides different types of priority classes according to this scheduling algorithm. So there are basically 6 types of priority classes. They are idle priority class, below normal priority class, normal priority class, above normal priority class, high priority class, and the last is real-time priority class. Now generally a thread belongs to a normal priority class until and unless its parents is belonging to any idle priority class or other class was specified at the time of the process creation. The priority of a class can be changed with the set priority class within the variable classes only, as real-time classes priority thread are considered to be constant during the execution of the system. Now related to this Windows API priority classes, there are integer numeric priority that is called the relative priority within the class that ranges from many numbers, and there are 6 different relative priority for the classes. They are idle priority, below normal priority, above normal priority, high priority, and time critical priority. Now this priority relative to any class can range from any number from 1 to 32, and based on which, as we have already described, they are considered variable and non-variable. Now a thread which have been prioritized or assigning a priority to each can be considered with two of the classes. That are, one is the priority class to which the thread belongs to, and within that class we have to consider the relative priority of the thread. Now as you can see in this figure that there are considering of the relative priority in this column left, and the top row is mentioning the actual classes. So if we consider that a thread belongs to an above normal priority class and which relative priority is normal, then can be figured with the 10 integer value from this table. Now there are also a base priority that is attached or associated with each thread that has been assigned at the time of the process creation, and that can range from any number within this table. Generally, the default base priority of any thread within any class is considered to be normal. Now we will see that there are different priority threads or different base priority associated with each thread for the normal class. Now the default base priority is the priority, as we have told, is the normal priority belonging to any class. However, we can change the base priority of these classes according to this setThreadPriority class function. Now using the function, we can change the priority or base priority of any thread that is associated with a particular class. Now consider the case that when a time quantum of a particular thread expires, then what happens? An interrupt occurs and the process will be preempted for some other processes. Now when this case happens, the kernel actually moves the allocation control from the CPU to the waiting queue of particularly that process. Now when the priority of the processes belongs to the variable class, then interrupt occurrence, the priority gets lowered. It's moved to a lower priority queue. But the priority cannot be lowered below the base priority attached to any of the threads. Now longer the CPU scheduling time that is attached to it is, the shorter the priority that it will be given. And shorter the period of CPU burst, then it will be given the higher priority. Now when a process goes to the sleep state or put into the waiting state, now upon resuming for the waiting state, the CPU scheduler actually boosts the priority of that particular thread which was waiting in the waiting queue. Now the boosting is depending upon the type of thread that it is associated with. Suppose if a thread is associated with the keystroke of the keyboard, then it will be given a high priority boost, whereas if the thread is concerning with any disk operation, then it will be given a moderate one. So the actual response is to give the more response time to the interactive processes rather than the CPU bound processes. Also, this priority maintains that the CPU bound processes will be given a spare CPU cycle to be run in the background, whereas the IO bound processes will be busy while doing the device's IO. Now, this strategy is used by many time sharing systems such as Windows and Unix. In addition, Windows also provide the interactive viz with any screen, Windows or desktop that it is the thread using will give a higher priority boost to actually give the response time more to the interactive processes. Now as we know that the normal class priority belonging to any Windows system or Windows API will have a predetermined or special rule of instruction or scheduling algorithm that is attached to it. Generally, we divide the process according to this rule with two different cases. Number one is foreground processes, that the processes are actually attached to any process or activities that is on displaying the screen, and background processes that are not actually displaying on screen. Now when the process moves from a background queue to the foreground queue, obviously the boost of high priority is given to it. Generally it depends on a factor, suppose say by factor 3. Then the interactive or foreground process will be given 3 times longer will be given 3 times longer burst time than any other real-time processes to be preempted for. Windows 7 introduced a process scheduling algorithm known as user mode scheduling. During this UMS or user mode scheduling, a user or application developer can actually create and manage threads without the actual intervention of the kernel. Now that the user application can create thread, the kernel can run its separate thread in the operating system only. Now, when the user can create more and larger number of threads, then UMS is specifically useful because no kernel intervention is actually necessary. Now, similar type of the scheme was run beyond this Windows 7 operating system was introduced, was known as user mode threads or user mode fibers. The fibers are similar actually to this UMS, but different that it was directly dealt by the programmer. And the fibers cannot make any system call because it shared a more common thread environment block to the actual thread where it belongs to. Now, any updation to this TEB made by this user application or the application programmer then can be overwritten by another fiber that is running on that thread. Now, if the thread that is actually running can update the TEB, then it will only override the TEB for that particular fiber along with the fiber that was previously write to that TEB. Now, the UMS can provide solution for this remedy as it uses each thread context for each thread it has created. Now, as UMS is not directly dealt by the programmer, that is better than the fiber. And UMS also provide this type of scheduler using a complicated algorithm. But this algorithm is done by the concurrent programming languages, which is actually built over the top of the UMS. Windows provides such concurrent actual programming languages like Concerti, which can be built to this UMS scheduling algorithm. Windows provide this kind of concurrent programming languages known as Concerti, which can be built to this UMS scheduling algorithm, along with the facility that it provides that it can divide the program into smaller tasks, which can then run on the SMP architecture or multiple processors individually and parallelly. Thus, UMS is better than Fiber and it is implemented in the Windows API for the better use of system performance and scheduling algorithm it provides. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.